Hi guys, welcome to another episode of MrLopezClasses.com. This is the chapter 6 of our book Corrosion. And in this chapter we are going to analyze how the current affect the process of corrosion. How the current accelerate the process of corrosion. And how can I identify if I have leaks of current in my boat. This is a hard chapter. I need that you follow me, repeat the videos, ask questions, send all the questions that you have to my email info@mrlopezclasses.com. I will be ready to respond, ready to clarify those questions. We are going to return to our book of electricity. And we are going to review the chapter 10, the chapter 12. Why? Because we are going to refresh the concept of bonding, grounding, the concept of the installation of the galvanic isolator, the difference between the galvanic isolator and the isolator transformer. We are going to check what happens if you have reverse polarity and why the process of corrosion is accelerated if you have reverse polarity. Yes, yes, yes. It's catastrophic if you have reverse polarity in a boat. Probably in your home, no, but in a boat, yes. Yes, we are going to review a lot of concepts that we learned in our class of electricity. And we are going to check some portions of those videos, because in those portions I explain with a lot of details those phenomena. For that reason, we are going to verify slowly each of those parts. We are going to check quickly the factors that affect the corrosion. It's clear that the corrosion process of metallic elements on the boat depend on the metal, depend on the alloy, and depend on the quality of the seawater. Remember, depend on the salinity of the seawater, depend on the temperature of the seawater, depend on the pH. All of those factors affect. But in general, there are metals in direct contact with the water, like the propeller, the through holes. Those elements are in direct contact with the seawater. And there are other elements inside of the boat. They are not in direct contact. But all of them will be corroded if the boat is not properly bonded, is not properly grounded, if the boat is wet internally. Yeah, if you have leaks of water, and those leaks of water are accumulated in the surface, producing stagnant water, this is not good. And of course, the leaks of current. And we are going to learn in this chapter the process to identify where are those leaks of current. If the metals are in direct contact with the seawater, there are a lot of factors that affect the acidity and the alkalinity, of course. The straight currents. The straight currents are coming from AC and DC, both of them. The cathodic protection, the sacrificial anodes. The permanent contact in between the water and the similar metals, galvanic corrosion, and the bonding system. That's important. Also, if the metal is not in direct contact with the water, it's affected. Depend on the humidity of the environment, depend on the straight currents, once again, depend on the pollutants in the environment, depend on the bonding system, the coating protection. And other factor that I want to add it here is reverse polarity. We are going to analyze what happens if I have reverse polarity in my boat. Why the corrosion and the destruction of the boat will be accelerated. Yes, and what type of current produce corrosion? Both of them, both of them. But at the end of the day, both of them produce static electricity, and that static electricity accumulated on the metals, DC current, is the current that creates the problems. But both of them produce problems. In other words, if I have a boat only with DC current, a small boat, those boats are less propense to corrosion. When I introduce AC current in my boat, when I introduce AC panel, battery charger, and other equipment, shore power and pedestal, my corrosion problems are accelerated. Yes, my friends. yes. And no problem. We are going to analyze the process to identify where are the leaks. Until this moment is clear. Until this moment, this chapter is clear that we need to keep the boat clean, dry as possible. Yeah. And we need good electrical connections, and we need bonded everything to the bonding system. For that reason, we are going to start checking again those three concepts: bonding, grounding, and ground. What is the main difference between both of them? And after that, we are going to return to analyze the galvanic isolator, yeah, the difference between the galvanic isolator and isolator transformer. And in other episode, probably we are going to analyze why the reverse polarity is catastrophic. Okay, we are going to review a video that I did years ago related with the bonding, grounding, and ground. Now I want to explain how important is the ground in your boat. 95% or more of the problems in a boat are electrical problems. All the problems, the majority of the problems in a boat finish in an electrical problem. And 95% of the electrical problems are related with a bad ground, or loose ground, or corroded ground, or bad terminals, or improperly wired the ground. In other words, the majority of the electrical problems in a boat are bad ground. The bad ground is critical. The bad ground can produce shorts, flame, fire. If you have a loose connection on a battery, for example, you have batteries connected in series, 24 volts batteries, and the cross cable, you remember the cross cable of the series, the negative with the positive, that cross cable is loose, and this is the battery bank for the bow thruster. In the moment that the captain activates the bow thruster, the batteries explode. Or the start motor in a big engine, diesel engine. If the negative is loose on the battery, during the cranking, you can explode the battery. The negative is critical. Or the typical example, the customer complains, oh, when I start the generator directly on the control box, the generator starts properly. When I try to start the engine from the flybridge or from the pilot helm, the engine no start. This is no ground. The batteries on the flybridge are not connected with the batteries on the engine room. Those battery banks are not connected to the negatives. In other words, the negative is critical. The ground is critical. But let me I refresh a couple of concepts before I continue with the explanation related with the ground. Bonding, grounding, and ground. What is the meaning of bonding? Bonding is the referral, the network, the connection of all the metallic parts or elements inside of the boat connected into the bonding bus bar. all the metals inside of your boat should be connected to the bonding bus bar, the bonding conductor. That element normally in a boat is a long piece of metal on the stringers. A long piece of metal normally is a copper, and on that piece of metal all the metallic elements shall be connected to the bonding conductor. Fuel tanks, if the fuel tanks are metallic, aluminum or stainless steel. Blocks of the engines, block of the generators, through holes, metallic through holes, cabinets. All the metallic parts inside of the boat shall be connected to the bonding conductor. Oh, if the metallic element is located above the waterline, it's not necessary connect to the... Yes, all the metallic elements inside of the boat should be connected to the bonding conductor. For example, the chain of the anchor is over the waterline, shall be connected to the bonding system. The anchor, the rail, the tower for the fly bridge in aluminum shall be connected to the bonding. All the metallic parts in the boat shall be connected to the bonding. That's mandatory. Bonding is the internal connection of all the metallic elements to the bonding conductor. This is bonding. Grounding is when you connect that bonding conductor externally with the sink on the transom, the sink that you have on the screen right now. That connection in between the bonding and the external sink, this is grounding. And ground is the referral to the ground. It's the direct connection to the ground. That's clear? Bonding is the internal connection of all the metallic parts on the bonding conductor. And grounding is this connection, the connection in between the bonding conductor with the external sinks. Alright. How many ground bus bar you have in your boat? A lot. In your boat, normally you have AC panel. This is the typical AC panel. Shore power, inverter, generator, AC panel, isolator transformer, galvanic isolator, bonding bus bar, and sinks. This is the typical AC panel. Voltmeter and meter and frequency. AC panel. And this is the DC panel. The typical DC panel with the DC panel, negative bus bar, positive bus bar here, over there. And this is the DC panel, positive bus bar, and this one is the negative bus bar. And this is the ignition bus bar. And this one is the electronic board. This is the electronic element. This is the main screen. The computer for the autopilot, the computer for the transducer, the backbone, the NEMA backbone. The electronics, they have one negative bus bar and other positive bus bar inside. All the negative bus bar, this one of the electronics, the negative bus bar, the ground bus bar on DC, the ground bus bar, this is the ground coming from the shore power enter here, this is the ground bus bar in AC, with the negative bus bar in electronics, with the main negative bus bar of the DC, the main negative bus bar, all of them shall be connected with the bonding conductor, and the bonding conductor with the sink. Once again, the negative of electronics, the negative bus bar of the DC panel, the ground bus bar on the AC panel, all of them shall be connected at the end with the bonding conductor, and the bonding conductor finish into the sink. This is mandatory. In DC, I have more than one negative bus bar. I have one here, I have other one here, I have other one over there. All of them shall be connected together with the main negative bus bar, and the main negative bus bar connected with the bonding conductor. Oh, I have 6 groups of batteries in my boat. No problem. The only that you need is verify that all of those groups, the negatives, are connected together with the negative bus bar, the main negative bus bar, and the main negative bus bar with the bonding conductor. This is the most important part if you want to have the boat properly protected. The bonding bus bar, if you remember in ABYC, how much is the current normally on the bonding bus bar? It's supposed that it's 0 or a little small DC currents. The bonding bus bar is a bus bar used to drain a small DC currents. Where are coming those small DC currents? Those small DC currents normally are static electricity from appliance, from equipment. Static electricity. The static electricity is DC. Let me explain. Where is coming the static electricity? Suppose that you have an appliance, the dishwashers. The dishwashers internally have an AC motor, single phase or double phase, normally. Okay, internally, the appliance have an AC motor. When the AC motor is running, is spinning, is producing power, depending on the insulation of the motor, there are some electrons that jump into the case of the dishwasher or appliance. For that reason, all the appliances, they have one green cable connected from the case into the bonding. What is the function of that green cable, green color, connected here? Oh, the function of that cable is to drain the static electricity accumulated on the case of the dishwashers. Remember, when the motor is spinning, some electrons jump into the case of the dishwashers, metallic, and the case is saturated with electrons. Suppose that you don't have that green cable, that drain cable. What happens when you touch the case of the dishwasher? Oh, you feel static electricity. In that moment, the static electricity is drained into the ground through your body. Your body is the green cable to drain the current. For that reason, to avoid that charge, you need to connect the body, the case of all the equipments to the bonding system in order to drain static electricity. Okay, let me rephrase. The AC motor, during the operation, send electrons into the case of the equipment, and the case of the equipment stores that electricity. When you storage electricity in a case, this is DC. Right now, that DC current, static electricity, is accumulated on the case and is drained through the bonding or grounding cable, green color. That's clear? What is the function of the ground or grounding cable used in the majority of the equipments or appliance in your home? Is to drain a small DC current. What happens if for some reasons internally in the appliance there are a short to ground? What is the meaning of that? In one moment, suddenly the hot touch the case. 120 volts touch the case. What happened with that excess of current? It's drained here. For that reason, the diameter of this gauge, the gauge of this wire, is enough to support in emergency big currents. Or during the lightning, during the storms, high voltage, millions of volts, can be drained through this cable, goes into the sink and is dissipated in the water. Once again, in normal conditions, through the bonding conductor, you have a small DC currents draining. In emergency, the bonding conductor is designed to drain big amounts of AC or DC currents. That's the function of the grounding system. And this is the secret to keep everything connected to the bonding conductor and finally into the sink. In specific, in electronics, the negative bus bar, this one, is critical. In electronics, the negative bus bar is very important. If the negative bus bar is loose, if the terminals of the cables are improperly connected, if the cables are corroded, you introduce into the electronic equipment noise and interference. If additionally the negative bus bar of my electronic equipment is close to the alternator or star motor or inverter or generator, those equipments produce too much electromagnetic interference. That electromagnetic interference affect that negative bus bar and affect the operation of radar, GPS, transducer, all the electronic equipment. For that reason, you need, when you install that negative bus bar in electronics, it's mandatory that you remember what is the tool recommended to identify the electromagnetic interference around this area? Yes, the gauge meter. Use the gauge meter that you have on the screen right now in order to identify how much is the electromagnetic interference here in this moment around the negative bus bar. The negative bus bar is a critical element in the installation of electronics. We need to verify that this negative bus bar is properly installed, is properly insulated, is properly bolted, and the terminals over there are properly crimped according with the procedure that I explained in previous episodes. Once again, the negative doesn't matter if it's for electronics or for AC or for DC, all the negative bus bar should be properly installed, properly connected. The cable should be professionally crimped with a heat string, properly isolated. This is the function of the negative bus bars in DC panels and ground bus bar in AC panels. Remember, all of them converge into the bonding conductor, and the bonding conductor finish into the sink. Okay, right now we have clear what is bonding, what is grounding, and what is ground. Okay, it's clear that I can create the leaks internally in my boat, the leaks of current. But what happens when the leaks of current are coming from outside? There are two possibilities. When I connect the shore power of my boat into the pedestal, if the pedestal of the marina is not good, if the ground of the marina, if the ground of the building is not good, is contaminated, that contamination, that bad ground enter in my boat and affect my boat. This is one possibility. Okay? Other possibility is my boat is floating on the water in the marina and the neighbor boats have leaks. And those leaks goes through the shaft and propeller and enter and penetrate my boat. You have two possibilities. Alright, how can I protect my boat to avoid those inconveniences? With the galvanic isolator. Yes, the galvanic isolator is, you remember, in the electrical classes, we understand where are located those galvanic isolators and how is installed the galvanic isolator and what is the function of the galvanic isolator. Yeah, we are going to refresh that concept, the galvanic isolator. Hi everyone. Today I am going to explain the procedure to install and verify if the galvanic isolator is working in good conditions. Some people confuse the galvanic isolator with the isolator transformer. the function is completely different. Today, we are going to talk about the galvanic isolator. Basically, the function of the galvanic isolator is avoid the intrusion of bad currents from the shore power. If the shore power of the marina or if the shore power of the building is contaminated, when I say contaminated, I am talking about noise, interference. If the ground in the building is contaminated, the current coming from the building enter into the boat and contaminate the boat, creating corrosion and oxidation in all the metals. Where is located the galvanic isolator? The galvanic isolator is inserted in series into the ground line. The ground is cut and you insert the galvanic isolator in between, in series. What is the function of the galvanic isolator? Block the intrusion of bad currents inside of the boat. Now I am going to explain the procedure to verify if the galvanic isolator is working properly. The first step is disconnect both terminals of the galvanic isolator. With a piece of wire, make a chart in order to discharge the galvanic isolator completely. Internally, the galvanic isolator have a capacitors and a couple of diodes. When you do the chart, you discharge the capacitors. Right now, the galvanic isolator is completely discharged, and we are going to check the galvanic isolator step by step. The first step is check the voltage. We are going to select in the voltmeter the function diodes. We are going to select diodes, and we are going to read the voltage in both directions. Now we are going to check the voltage in this direction. Normally, if the galvanic isolator is in good conditions, the voltage rise from 0 volts until 0.9 maximum 1 volt. If the reading immediately when you connect both terminals, if is 0, is because the capacitor internally is defective. If you read 0.9 immediately, it's because one diode is in short. If you read 0, it's because both diodes are open. Okay, we are going to verify right now in this example what happened with this galvanic isolator. We are going to check. Okay, now 0.1, 0.2 volts, 0.3, 0.4, 0.5, 0.7, 8, and we are going to reach the maximum is 0.9. Is 0.9. In this way, the galvanic isolator is good. Now we are going to check in the other side. Once again, we are going to make the chart, and now we are going to connect the terminals of the multimeter in opposite way. Okay, right now we are going to start. Now, okay, 0.1, once again, is rising, 0.2, 0.3, okay, 0.4, 0.5, the voltage is rising, and 0.7, 8, and once again 0.9. In both sides is perfect. That galvanic isolator is working properly. That's the procedure to verify if the galvanic isolator is working or it's not working. If the galvanic isolator is not working, it's basically because you have too much corrosion inside of your boat. It's because the corrosion destroyed all the metals. Remember, all the metals inside of the boat shall be connected to the bonding system. Thank you. And of course, the galvanic isolator is completely different than the isolator transformer. It's a different element. They have different functions. For that reason, you need to be clear about the isolator transformer, where it's located, the galvanic isolator, where it's located, what is the function of the galvanic isolator, and what is the function of the isolator transformer. This is the main difference between galvanic isolator and isolator transformer.
Hi everyone. Today I am going to explain the main difference between the galvanic isolator and the isolator transformer. The function is completely different. If you remember, in other of my videos I explained the procedure to verify if the galvanic isolator is working properly. Basically, the galvanic isolator is located inserted in the ground line. The ground that is coming from the shore power entering to the boat. If the ground coming from the shore power is contaminated with noise or interference, the ground entering to the boat and create corrosion and oxidation and damage all the metallic elements inside of the boat. For that reason, the recommendation is insert in series in the ground line the galvanic isolator. Basically, the galvanic isolator is located, this is the ground coming from the shore power, pass through the switch selector, enter into the boat and go directly to the ground bus bar. Before the ground line enter into the ground bus bar, you cut it and you insert the galvanic isolator. Of course, after that, the ground bus bar shall be connected with the bonding system and the bonding system finish into the sink. On the other side, the isolator transformer is completely different. The isolator transformer receives the signal hotline, neutral and ground from the shore power or from the generator. The signal enter, pass through the isolator transformer, and after that the signal is completely clean. The function of the isolator transformer is clean the signal. Why? Because in some cases the signal coming from the shore power is contaminated with noise and interference. The galvanic isolator, by induction, creates a new signal completely clean. If you remember, this is the picture for the galvanic isolator. The signal is contaminated in the input, and in the output the signal is completely clean. Where is located? This is the shore power, enter into the boat, or the power from the generator, pass through the switch selector, you select generator or shore power, and from the common you insert the isolator transformer in series, hotline and neutral, and the output is the clean signal. The clean signal enters into the main breaker of the AC panel. The ground is outside. In the ground you insert the isolator transformer, and in the hotline and neutral you insert the isolator transformer. The function of the isolator transformer is clean the signal, and the function of the galvanic isolator is block the intrusion of bad currents through the ground. That's the main difference.
Okay, my friends, I hope you enjoyed that explanation. And now, in the next coming episode, we are going to check reverse polarity. But we are going to check the wiring completely and how the reverse polarity can affect my boat.